everyone, welcome back to A-Level Lessons Online. So we are doing our H2 Math 2017 Paper 2, looking at question 4 today, alright? A question on integration that it's slightly challenging, okay, but it's definitely quite fun to do, alright? So sit back, grab yourself your pillow, grab yourself a notebook, grab what you need to grab, and we're going to do this question together. Alright, so the question goes for part A. A flat novelty plate for serving food on is made in the shape of the region enclosed by the curve. So is region enclosed by the curve y equals to x squared minus 6x plus 5 and line 2y equals to x minus 1. Find the area of the plate. Alright, so this is looking at an integration question on area. So it is basically just finding the two curves, seeing where they intersect, and then finding what the area is between them. Alright, so if you draw your diagram, I'm just going to draw a bit of a sketchy diagram over here. Let me just get a shape out, alright? So, okay. So let's say this is my y and x axis. So my y axis is here. X axis is here, right? If you plot this in your GC, you'll get something that goes like this. Okay, I know it's very shaky. My hand is currently very shaky. Give me 1 second. Let me try and draw this nicely. Alright, just something like this. Okay, this is the y equals to, it's the quadratic curve. So y equals to x squared minus 6x plus 5. And then you'll get a straight line as well, which just cuts through over here. Something like this. Right, and this is the equation y equals to x minus 1 over 2. Right, I bring the 2 over. Alright, so I've got equation 1, equation 2, which is my quadratic curve, and the equation of a line. So they are asking you for the region in between, which is this shaded region over here. So real quick, all you need to do for this part is very simple. You just need to plot it into the GC and find what the point of intersections are between the two curves, which you would find is very simply 1, 0, as well as 11 over 2, 9 over 4. Okay, so all you need to do now is just very simply find the area of this curve, which is the upper curve minus the lower curve. So in this case, if you can see, the upper curve is basically the part above the shaded area, which is going to be your straight line. And then the bottom part, okay, which is below the shaded area, is going to be the quadratic curve. Okay, so this is the bottom. And the top, I will highlight it as this part here. Okay, so now if we do this integration, it's very simple already. So the area of the plate would be equivalent to, okay, so your limits in this case, it's the x values, because since the curve, the shape of this plate, the area that you're finding is from an x value to another x value. So and also because the curves are already in that form, right, you're going to be taking y1 minus y2, so you will just get from 1 to 11 over 2. And the first curve is going to be x minus 1 over 2 minus the second curve, which is your quadratic equation, x squared minus 6x plus 5, and then you're going to dx the whole thing. So because they didn't state whether you need to put in exact form or what, you can just use your graphic calculator to solve this, and your answer will be very simply 243 over 16 units square. That's the answer to the first part. Right, quite a simple part. Okay, part B, they're asking you to, a curved container has a flat circular top. So the shape of the container is formed by rotating. So we're going to be looking at volume. Very clear signs here. Rotating the part of the curve, x equals to root y over a minus y square, where a is a constant greater than 1 between the points 0, 0 and 1 over a minus 1 comma 1 through 2 pi radians. Okay, so that is just a normal one whole circular area, one whole volume. Okay, whenever they say 2 pi, it's just 360 degrees around. So find the volume of the container, giving an answer as a single fraction in terms of a and pi. Alright, okay, the second part is, we're just going to read through also. Another curved container with a flat circular top. So it's similar as well. X equals to root y over b minus y squared. So it's the same equation. It's just that now you're subbing out a to be b. At the points 0, 0 and 1 over b minus 1 and 1. It has a volume that is 4 times as great as the container in part 1. So find an expression for b in terms of a. Alright, so these two parts are actually linked. So I'm just going to do it together. Alright, part B, part 1. Okay, so this one, if you actually draw the diagram, it looks something like this. So it basically has an asymptote that is above the axis, right? This is your x, this is your y, so it goes up. And then it comes. Okay, so from this from this diagram, okay, you can roughly see this part over here is where it's going to be rotating. Alright, so this point is 1 over a minus 1, 1. Okay, and this asymptote is y equals to root a. The entire curve is basically x equals to root y over a minus y squared. Alright, so this is kind of like how the curve looks like. So the part that's going to be rotating will be this part over here, the shaded part. Alright, so the volume, you're just going to use your x values as the equation, okay, to find the volume. Okay, and the limits they're going to be using, since you're using x squared, right, as the volume over here, you're going to be using the limits for your y values. So the volume, okay, we've already I'll cover this in a video for integration, right? So, but this is basically a formula that you need to know, right? Something that is part of your syllabus that you need to understand. So the volume would be from my limits, which is y0 to y1, correct? From this to that point that was given, and then the equation is just pi x squared dy. So all you need to do now is just sub in the relevant values. So this you will get equivalent to, I'll take out pi, integrate from 1 to 0 x squared, which is going to be root y over a minus y squared, whole thing square dy. Alright, always remember your square, okay, when you're finding volume. So from here you can just simply expand it. You get pi 1 0 times y over a minus y squared to the power of 2 dy. From here then you get pi 1 0. Okay, all I'm going to do now, I'm just going to bring the denominator to the top, so it becomes a minus y squared to the power minus 2 dy. Okay, reason being is that from this you can actually see that I can use my the identical forms. Okay, this is actually a technique, okay, that we use in, not identical, sorry, recognizable forms. Yeah, we can use recognizable forms for this part. Okay, you can see that the y in front, right, I can actually, it's essentially an integration of, a differentiation of the inside. So this is using my f prime x fx integration formula. So when I actually differentiate my negative y squared, okay, when I differentiate my negative y squared, I will simply get negative 2y. So which means that now I must make a negative 2y pop up somewhere. So all I'm going to do is just put pi 1 0, not 1, yeah, sorry, there's no fraction, 1 0. So if I'm going to put a negative 2y here, in order for it to be the normal y that it was before, I have to add in a negative half. So I'll add in a negative half to the front, and then I'll just get a minus y squared to the power minus 2 dy. So from here it's very simple. Okay, you can just get rid, okay, and then just continue your normal integration from here. Okay, get rid of the minus 2y. So you get minus half pi whole thing times a minus y squared, and then integrate, you always add 1. So you get minus 1, and then you differentiate it by the new power, which is minus 1 bracket 1 0. Okay, so this is where we've already integrated. Then after that, all you need to do now is just make it simpler to understand. You just get half pi times a minus y squared to the power minus 1, 1 0. So when you have got something to the power negative 1, is essentially an inverse. So you just flip it, get 1 over a minus y squared, 1 0. So all you need to do now is just sub in the 1 and the 0. You will simply get half pi times 1 over a minus 1 over a. Alright, so this part you can just make the same denominator of the 2. You get half pi times a minus a plus 1 over a times a minus 1. And your answer will very simply be just pi over 2a times a minus 1. Alright, so that's your answer. Very, very simple part to this part on the volume. So you can always write units cube. Alright, then the next part B, part 2. So part B, part 2. Okay, so this one is actually, if you realize, it's kind of like the same thing, right? So the question had already given you that you have this same equation with this same coordinate. So the coordinates over here they gave you is 1 over b minus 1, 1. So from here you can already tell that all you need to do is just sub, right? The thing, the a to become b, because the equation of the curves are exactly the same. So the volume that we found prior was pi over 2a times a minus 1. So all you're going to do now is just sub a to b. Alright, and all you will have is that the new volume of this new plate will be equivalent to... New plate volume is equivalent to pi over 2b times b minus 1. Alright, from the question they gave us that pi over 2b is actually b minus 1 is actually 4 times that of the original plate with a. So this will be 4 times of pi over 2a times a minus 1. So from this, we're going to try and make b the subject. Okay, so all you can do is just take out both pi, since pi cancel out, and you will get 1 over b. You can take out the 2 as well, get rid of that, and you will get 4 over a times a minus 1. So from here, we can just cross multiply. You get 4b times b minus 1 equals to a times a minus 1. After which, you can just combine it. 4b squared minus 4b minus a times a minus 1 equals to 0. Alright, so here is where you need to do your b square, your finding of your roots. Okay, take it that you have got your a, you've got your b, you've got your c over here. So your a, actually maybe we shouldn't, let's use capital A, okay? So this is basically finding the roots, okay, when you can't press this into your calculator. So a equals to 4, b equals to minus 4, big C equals to minus a times a minus 1. So if we sub this into your normal, let's say if you take it to be x, now you take it to be b, you get minus b plus minus b squared minus 4ac over 2a. So you get minus b, which is minus 4 plus minus. So this part is your b squared minus 4ac, b squared minus 4ac over 2a, which is 4. So from here you will find that b equals to 1 plus minus root of a squared minus a plus 1 over 2. So from here you can very, very simply just simplify it, right? Take out the 2, you get b equals to 1 over 2 plus minus half of root a squared minus a plus 1. So from here, then you have to read the question, okay? So from question, we have already understood that they want us to find an expression for b in terms of a. So since the volume of the second container, right, or the second plate, whatever the question was asking, okay, is more than the volume of the first container, it means that your b has to definitely be more than a. And since a cannot be 1, a has to be more than 1 as well. So we have already inferred, okay, that since the volume of the second container is more than the volume of the first container, okay, it is definitely so that b is more than a, which is more than 1, since the question already said so. So therefore your answer can only be one answer, it cannot be the negative. So therefore b will have to be equals to half plus half of root a squared minus a plus 1. Okay, so you reject the negative, okay, because your b is more than your a and a is more than 1. Alright, so there's only one possible answer. If your answer is a negative, that means your b will already be less than the value of a, which is wrong. Alright, so that's all for this question. It's not very hard, okay, just do it slowly and remember your formula, okay, your formula is very important here, okay, at least over here it's very straightforward that you have to use your pi x squared formula, okay, but if they don't give it clearly, you have to make sure you draw the curve and understand whether you need to use the y square or x square in the question. Alright, so if not, if you did enjoy this video, okay, be sure to give it a like, it really does help me out a lot, as well as to subscribe to the channel. It's free, it doesn't cost anything, so just hit the button and it really does help me out a lot as well. Any questions, you can leave it down in the comment section below and I will answer them too. If not, I will see you guys in the next one. Okay, we're moving on to stats already, very fast and very fun. Alright, so we're gonna look at stats. I think it's something that you guys are hopefully looking forward to. Okay, it's the easier part, I feel, of the paper. So let's look forward to stats, and we'll get through PNC and probability together. Those I think are the hardest of all. Alright, so I'll see you guys then. Have a good one. Bye bye.